Despite the fundamental differences between the planets of the solar system in terms of size, distance from the sun, and their internal composition, they all share one common feature: their spherical shape. All the planets in outer space are almost spherical in shape. And not just the planets. Most celestial bodies in space share this characteristic. This similarity makes us wonder, why do they all agree on the spherical shape? Why isn't there, for example, a square star, a cylindrical moon, or a pyramidal planet? Welcome to our channel Wonders of Secrets. But before we begin, if you're new to the channel, don't forget to subscribe and activate the bell so you can get our videos as soon as they're released. To understand the origin of the topic and the main reason most celestial bodies in space take on this spherical shape, we need to go back in time, specifically more than 4 billion years ago, when most bodies and planets in our solar system began to form. Let's start with the formation of the planets. Although we don't know exactly how it happened, scientists have some hypotheses. One of them is that there was an enormous nebula made up of gas and dust. Over time, more and more material began to revolve around it, and eventually the massive body that formed started collapsing inward toward the center. Due to the immense pressure, the center became extremely hot, hot enough to initiate nuclear fusion and convert hydrogen gas into helium. After that, the hot center of the nebula began spinning rapidly around itself and completely separated from the nebula. This marked the actual beginning of the formation of the Sun. The gravity of the newly formed Sun began to influence the remaining parts of the nebula, forcing them to either stick to it or revolve around it. During this time, dust and gas particles started forming rocks, and those rocks began colliding with each other while spinning. Each time rocks collided, they combined to form larger rocks. Due to the continuous rotation of matter around a single central point, a large number of particles began to accumulate within the forming planet. As the planet kept attracting as much material as possible, its size increased, and with it, gravity intensified until it reached its maximum. Some objects managed to escape the sun's gravity, others merged with the sun, and some settled into stable orbits to eventually form the final shape of the planets revolving around the sun. Interestingly, this whole story can be summarized in one word: gravity. Gravity is the force that keeps any body in the universe, not just in space, intact, coherent, and maintaining its apparent shape in a state of equilibrium. If we examine the role of gravity in any planet, we'll find its most important role is pulling all the material it consists of toward the center at equal distances from all directions. As a direct result of this material being pulled toward one central point, the spherical shape begins to form automatically. This is because it is the only geometric shape that allows equal distances between the center and any point on the outer surface during the gravitational process, and it's the only shape that allows the body to remain in a constant state of equilibrium. Another factor that helped form this spherical shape is the balance that occurred between thermal pressure, represented by the planet's tendency to release its internal heat outward, and the force of gravity pulling everything inward. This created a state of hydrostatic equilibrium, where the thermal pressure balances the weight of the material being pulled inward by gravity. As a final result of this equilibrium, the body naturally takes on a spherical shape. So since planets and stars are spherical, does this mean all celestial bodies in space are spherical too? The answer is no, because all the conditions we mentioned during the formation of planets or stars are not fixed and do not apply to all objects in space. There are specific conditions that must be met for a body to take on this shape. Many celestial objects are not spherical and have irregular shapes. So what are the factors that influence whether an object becomes spherical? The first and most important factor is the size of the body. The size determines the speed of rotation, gravitational strength, and many other important factors. As we mentioned earlier, any body in space mainly relies on its gravity. The larger the size, the greater the gravity. That means small objects in space, like asteroids for example, are not necessarily spherical. They might be roughly spherical but incomplete, because their small size and weak gravity aren't enough to provide the force required to maintain their shape against external forces. In the end, their shape is irregular. To give a rough estimate, we can say that any object with a diameter less than 1,000 kilometers, Or to make it clearer, any object less than 3.5 times the size of the moon is unlikely to form into a spherical shape. Even though being massive in space is a key condition for forming a spherical shape, something strange is that some very large celestial bodies still aren't perfectly spherical. To understand this, let's look at some examples from the planets of our solar system. Although the planets of the solar system appear circular, and we rarely draw diagrams of the 8 planets in the Sun without just drawing some circles with a compass, the truth is different. Some planets are fully round, while others are not. For example, Mercury and Venus are far more rounded than the other planets in the solar system. These are the ones we could call truly circular planets. On the other hand, planets like Saturn and Jupiter have much greater thickness at the equator than any other planet. Their shape isn't considered circular. They're closer to an oval shape. The main reason for this increased thickness is their extremely high rotational speeds. Saturn reaches up to 35,000 kilometers per hour, and Jupiter exceeds 47,000 kilometers per hour. This means that the faster a body spins, the faster its surface rotates compared to its inner structure, causing the equatorial diameter to be longer than the diameter from pole to pole. This bulge at the center is known as the equatorial bulge. It's worth noting that Saturn is the most visibly equatorially bulged planet in the solar system, even though it's not the largest. If we measured its diameter from the North Pole to the South Pole along its axis of rotation, we would find that the planet's overall shape is far from being a perfect sphere. On the other hand, for planets that spin at slower speeds and are smaller in size, like Earth and Mars, we find that these 2 planets are closer to a spherical shape, though not perfectly so. For instance, Earth's equatorial bulge is about 0.3%, and Mars is about 0.6%. Since the bulge in both cases is less than 1%, we can conventionally call their shapes spherical. Despite the slight differences in the shapes of planets, they remain among the clearest spherical forms visible in space. Finally, we'd like to clarify that no matter how varied the shapes of celestial bodies in space may be, most of them had the same origin, a spherical shape formed due to gravity and pressure. Some managed to maintain their shape until now, and others changed completely. That's it. We're done. Who made it this far? Everyone who did. You're the best. Leave us a like before you go so we know how many reached the end. And don't forget, if you have any questions that confuse you, write them in the comments under the video so we can answer them. Goodbye.